Okay, so in this video I want to discuss the use of these time-of-flight sensors. Now these time-of-flight sensors are basically range finding sensors, and they tell the distance between the object and the sensor itself. Now this might sound a bit familiar to you, and a lot of people will be familiar with ultrasonic sensors. Ultrasonic sensors work kind of the same, but are an older technology. So these are ultrasonics. They use by sending out ultrasonic waves, and basically you're going to have your transmitter as well as your receiver. One transmit the wave and bounces back off the object and comes back to the receiver, and then it can basically calculate the distance of the object from the time between those two separate things happening. Now your time of flight sensor, which you can see two separate units here, works quite similarly. It uses a laser, hits out off the object, comes back and hits off a sensor on the sensor itself, and then by that it can determine the distance of the object. Now, what are the differences between the ultrasonic and these time-of-flight sensors? Well, your ultrasonic is an older technology. It's quite larger than these time-of-flight sensors. As well as that, they're quite smaller, the units themselves. And these time-of-flight are a lot more accurate than your ultrasonic. So the readings that you get are going to be a lot more accurate and consistent than the ultrasonic. And as well as that, they work quite a lot faster. So you actually get that reading back to your microcontroller, whatever that's going to be. In this case, we have our microbit and our Keytronic all-in-one breakout board. But there is one downfall in comparison to the ultrasonic sensor, is the distance that it works at. Now you still do get quite a good distance out of it, maybe 20 or 30 centimeters, but past that it tends to degrade fairly rapidly, while your ultrasonic tends to work a bit further distance wise. But now that we've discussed what they are and how they work and what the difference is between the ultrasonic sensor, I'm going to show you how to wire it up to your microbit. Now from these two units, I didn't have much success with this model of time of flight, working with the microbit. Luckily, we actually have an extension that's provided quite recently up on the microbit code editor, which works with this model here. Now I'll indicate the model itself on the video title, but you should be able to get it from the bit of writing that's here. Let's turn it around. There you go, WCMCU531. And you can see we have a few different pins on it. We have our VCC, which is at the top, which is going to be your power. 3 volts would be sufficient. You have your ground pin, and you have SCL, SDA, and then you have these two separate pins below here. Now, for the purpose of this video, we're actually going to ignore these two bottom pins, and we're just going to use our VCC, our ground pin, and our SCL and SDA. So let's wire it up, and then after that, we'll have a talk about the code itself. As we have a look at the wiring diagram here, I just want to talk us through how it works. Now, it's quite simple. You can see that we have 4 connections. We're not actually going to use these 2 connections here at the end of your sensor, but we are going to use your VCC, which is going to be your 3 volts, your ground pin, which is going to go back to your ground, and we're going to use these 2 new pins here, the SCL and SDA. Now, the SCL and the SDA both have to connect to a specific pin on the microbit itself, or breakout board. Now those pins are pin 20 and pin 19. Now, to know why you have to do this, you need to have an understanding of the pins itself on the microbit. So if we have a look here, a bit of a breakout of each of the pins at the bottom of our microbit, we can see, what each of these pins can do. And as you can see, there are certain pins here that can read analog signals, digital signals, as well as additional functions, as you can see throughout. But the main thing we're looking for here is the pin that can read SDA and SCL. So that's our pin 20 and pin 19. So SDA is pin 20 and SCL is pin 19. So the only 2 pins we can connect basically these 2 pins back here to are 19 and 20, ensuring that you have the right one connected to 19 and 20, not the opposite way around. Now that we've cleared that up, you can actually put it together. And as you can see here, we are just using our headers here in our breakout board. And this header is representing all the pins, as you can see here on the microbit. So we're just going to connect to that. We've connected it to, if we can see, bring the light over. We've basically connected up to our ground, our 3 volts, our pin 20 and our pin 19, and they are all going to their corresponding pins here on basically the time of flight range sensor. Now all we have to do, that we have that sorted, is put together a bit of a code, and then we can test out how it works. Okay, so now that we've moved over to our microbit code editor, what we can do is we can start working on the code itself. So we can start off by deleting the onStart block. We won't be needing that. But we will need to add an extension and use our forever block, because we want the code to run forever so that it can continuously tell us the measurement that it's getting from the time of flight sensor. Now we're going to go to our extensions below here, and we're going to put in time of flight, like so, and then this extension is going to pop up. Now, as you can see, this extension is only for the range sensor that we're using, so the VL53L1X. So that particular sensor here, time of flight sensor, is the one that they have put together this extension for. So if we click on that, now what we're going to get is we're going to get this new tab, which is called Range Finder. Now in that, there's going to be 2 new blocks. Both of these blocks you'll need to use. Always you're going to use this initialize block first of all, so that the sensor initializes itself before use. That's always going to be before wherever this distance block is used. So I always put it at the very top of my code itself. Then what we want to do is to read out the number on our 5x5 matrix of the microbit. So the 5x5 matrix you can see here, for it to read out the number in millimeters, what we're getting from the object that's going to be in front of the sensor. So we'll go to basics and we'll go to show number, drop that in below, and then we'll go to our rangefinder tab again, and then we're going to drop in distance in millimeters in here. Now, if we just upload this code straight up to our microbit, we'll start to be able to read the distance from the microbit itself, or from the sensor itself, to the object that's in front of it in millimeters, and that will be displayed up in this 5x5 matrix. But before we do that, upload this code, I also want to show you how you can use this to potentially, let's say, run a motor or make a noise if it senses an object within a certain range. So for instance, we can just duplicate this here for now and put a separate piece of code together, and we'll ignore this bit, okay? So we can delete our show number, we can leave our initialize and our forever block, and we can go for logic this time. So if we go to logic, and we go to if true, and we'll drop that in here like so. Now we don't want if true, so we'll go back into our logic and we'll go to our comparison block, and we'll just drop it into here where true was. Then we can go to our rangefinder and get our distance in millimeters and drop that in here. And then we can say if our distance is less than, so we'll go for less than or equal to, let's say maybe 100 millimeters, okay? So if our distance is going to be less than 100 millimeters, something, whatever's inside here, is going to happen. So let's say, we'll say we could put music playing, so we could put a sound that plays. So what happens if it's less than a certain distance, so that 100 millimeters, an object in front of it will start to make this noise here, which you can just hear there. It's a chew, chew, chew sound. Or you can do something, let's say, like run a motor. So for instance, you could put an extension, Kachonic all-in-one breakout board, and you can put in motor and get that to run under a certain distance, or whatever you would like to work. But for the sake of this demonstration, all we're going to use is we're going to use this bit of code we had at the start, where we have our initialize, We have our show number and distance in millimeters, which goes showing that 5x5 matrix. Okay, so now that we know our code, we can upload it to the microbit itself, and we can turn on our microbit by turning on the power switch back here. And we should be getting our reading for our distance. So for instance, I have it pointing directly at the camera itself, and I can see that it is 501 millimeters away from the camera. So if I do that again, sorry, it's 181, 181. If I bring it a bit closer, 105 millimeters away. Now, just to test the accuracy of this, we can set it up like so. I'm just going to use a few clips to hold it nice and steady. Then I'm going to get a vernier calipers. And we're just going to use the measurements in the vernier calipers and roughly set it up to how we want it. Great. So now I can read out the measurements. If I put something here for the laser to bounce off of, we'll see what it reads. It should be about 150. So if I read it now, 107, so 107 millimeters. Set it up a bit better. Try it again. 142. Okay, so about 5 centimeters off of what I have it at, or 5 millimeters. If I bring it into about 100, let's wait for it and wait for it to refresh. 86, so 86 millimeters, so not far off. Bring it in a bit closer to 60 millimeters. And we're getting 61 millimeters, so 1 millimeter off. I'll bring it into 40. It's reading 37 millimeters. Now it's reading 40 millimeters. Now if I bring it back out to 80, and we're getting 76 millimeters. So as you can see there, it's quite accurate, a lot more accurate than you would have with your ultrasonic sensor. But you can see as we move further out along the measurements, the measurement or the readings that's get less accurate. So if I bring it out here to 150 again, I can see that it's 166, so it gets thrown out that bit further. So it prefers to work at a closer range. So for instance, when I have it here, it reads exactly 46 millimeters, which I'm just about 42, 43 here.